Assalamualaikum warahmatullahi taala wabarakatuh. Experiment specific heat. Story behind the experiment. Specific heat, noted as C, is the heat required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. The amount of heat required, Q, to change the temperature of a substance is proportional to the mass m of the substance and to the change in its temperature delta T. Mathematically, it is written as Q equal to mc delta T, or can be rewrite C as Q over m delta T. The procedure of this experiment: by using an isolated vessel, i.e. calorimeter. So this is the calorimeter. Scientific technique, i.e. calorimetry. So the technique is known as calorimetry. And assuming no heat loss to surrounding, then a physics principle of conservation of heat then can be applied to calculate the value of specific heat, which state that heat loss by hot object equal to heat gain by the cold object. So the setup of this experiment will be as shown here. Okay. To boil water by using this steam generator. So you need to fill this steam generator with the cold water, and then you switch it on, and then you let it boil for a while. But while waiting for the water to boil, you need to do some procedure, which is first you need to measure the mass of this sample. In this case, is aluminium. So I will use electronic scale balance. So here is my electronic scale balance. I will use this to measure the mass of this sample and record the mass. Once finished, I will measure the empty and dry calorimeter. So this is empty and dry calorimeter with the cover. So I will measure the mass. Once I measure and record the mass, I will pour a cold water inside this calorimeter. So I will pour the water. So make sure the amount of water is enough to fully submerge the metal that you will put into this calorimeter. So make sure it is just enough to submerge this sample. Okay? So once you have measured the mass, so you need to put the cover back, and then you measure the mass of this calorimeter with water inside, and then from this you'll be able to determine the mass of water, which is the difference between mass water with calorimeter minus the mass of empty calorimeter. So that will give you the mass of water. So once you finish measure the mass of water, so you need to use this. This one is a digital thermometer. You need to measure the initial temperature of this water. Okay, measure the initial temperature of water. Then you keep the record as the initial temperature of water. Once you have measured the mass of this sample, which is aluminium, and the mass of water inside the calorimeter. So the next procedure is you need to hang this sample inside the steam generator where you have the water that already boiled. Okay, so in this process, make sure when you hang, make sure that the base of this sample do not touch the base of this steam generator. Why? Because we want the heat exchange just happen or occur between water and the sample. So during the process, you need to use this cover to make sure that there is no heat loss to the surrounding during the process. So these are the process that I will do. Okay, so make sure it do not touch the base of this steam generator. Cover it, and then for this process, you need to give around 10 minutes for both water and the metal to reach thermal equilibrium. So after the 10 minutes, so you need to open the cover, and then using the digital thermometer, and then you need to measure the mass of water. So in this process, you are actually measuring the mass of the sample. Why? Because after 10 minutes, both water, the hot water, and the sample will reach thermal equilibrium. So it means that the temperature of water that you measure is the same with the temperature of the object, which is in this case is aluminium. So after you measure the temperature, the initial temperature of this metal, quickly remove and wipe with the towel. So in this process, you need to do it quickly. Why? Because you don't want to affect the initial temperature of this hot metal. And then why you need to wipe? Because you need to remove any excessive mass of water. Then this process you need to do quickly because you need to prevent any heat loss to the surrounding. So you need to put this metal, mix it with the water inside the calorimeter, put it into this calorimeter, and then you hang it using this retort stand. But before that, you need to cover it with this cover because you want to prevent any heat loss. Make sure it is fully submerged, and then you hang it. And then you use your digital thermometer. Then you measure the mass of this mixture. What you can see here from this screen of this digital thermometer, you will see that there will be slightly increase in temperature. It means that the heat already exchanged from the hot metal to the cold water inside this calorimeter. Okay, so it will increase until it becomes static, whereby there is no increase. Okay, it means that both water and hot sample now reach the final temperature, which is known as the thermal equilibrium temperature. So you will record it as a T equilibrium. Okay? This the part of the last part of this experiment specific heat, whereby you need to do some treatment of result. So in this treatment of results, you need to analyze your data. So table 5.1 here shows to you the data that you already recorded. So for that experiment just now, you need to repeat for lead and copper because I just shows to you for the aluminium. So these are the things that you already recorded just now. And then to calculate the specific heat of this aluminium, copper, and lead sample, so again, you need to use a principle of physics, which is you need to use the conservation of heat. So under this conservation of heat, the heat loss by the sample, so in this case is the hot aluminium, is equal to the heat gain by the cold water inside the calorimeter. But as you know that in this case the Q is mc delta T, so you equal mc delta T from the sample, but since it is a loss, so you put it negative here, indicate the heat loss equal to the gain. So in this case, the heat gain is from the water. So whereby you will use expression 5.2. So from this expression 5.2, with all the data that you already gained in this table 5.1, you'll be able to determine the specific heat of the sample. Trivia. Scientists found that water is incomparably the best liquid option for staying hydrated and healthy. Plants and animals are mostly water inside and must drink water to live. It has a highest specific heat capacity to hold 4,186 joule of heat for temperature change of 1 degree Celsius. Allah subhanahu wa ta'ala, the most great creator of mankind and merciful. Thank you very much.